Almost sounds like a tongue twister. Anyways, today I'll be presenting about my experience of getting into Python. When I joined IBM, my team is actually very pro-Python, so I got an opportunity to learn and know more about Python. And this is what I was planning to present in this presentation, basically to give you some idea about how it would look like if you decide to get into Python. By the way, I'm assuming that the target audience for this presentation is people who don't know Python. So if you already know Python, then you might not get much out of it. The other goal is to basically give some resources, some pointers, not go into details, so that when you get started into Python, you have something to start with. And if you have not checked out e.t.c, please do so. This presentation will encourage you to do so. I will go ahead to the next slide. So first up, to starting with Python would be to install Python. At that point, you will have to make a choice of the version you're going to build on. Ideally, yeah, you can support both versions, Python 2, Python 3. But if you're a beginner, I would suggest choose one. It would seem like we should go with Python 3 because Python 3 is where the new releases, new features will be. But I decided to go with Python 2.7 because a lot of third-party libraries, etc., which you might be using, might not be already ported to Python 3. So when you are starting, you don't want to get into those issues that you're using a library and it is not ported to Python 3 and your project is in Python 3. So to avoid that, I chose Python 2.7. And I like IDEs. So I remember there were a lot of questions what IDE you would use. You can use Vim, you can use Sublime. My team loves Sublime. I decided to go with PyCharm. It works well on Windows. It integrates well with Git, pip, etc. So I like it. And version control, I decided to go with Git because a lot of Python packages, etc., are on GitHub. So if you notice something, if you want to fix something, you can just git clone and make a patch. Once you have all these things, you will be all set to start with Python programming. And the first thing you'll notice is the absence of block delimiter, the absence of a keyword for a block delimiter. I come from C. Before Python, I had programmed in C for like 5-6 years. And that was something very new to me. I felt like the need for closure. But I can attest to you, when you're in the zone, you're writing code, you have written a lot of code, and then you find out you missed some opening braces, it is very unsettling. So in Python, you don't have to see that. That is awesome, but it takes some time to get used to the whitespace delimiting. Because since I've programmed, I never realize that white spaces and blank lines could be so important that it can break your syntax. So one big thing that I noticed was Python is very big into readability, which sort of shows that indentation is mandatory. You'll break your syntax. So Zen of Python is basically beautiful is better than ugly. Yeah, not in terms of humans, but in terms of code. And Python is designed like that so that you're forced to write good code. You're forced to sort of make beautiful code. And the Python community has come up with like Python style guides, which helps to tell you basically how a good code would look like. And the good thing about Python is if there is a style guide, there will be a style guide checker. So Pipet is a style guide checker. You can easily install it, and when you run it, it will show you where all you have violated the guidelines. You can use Pylint, that is for even more static checking, etc. So these are all these good tools which enable you to write visually uncluttered software, which is very important for maintainability of the software, readability of the software, which I realize makes Python so popular. Next thing you would notice is, sadly, no compiler breaks, no Facebook checks, no news updates, because Python is a scripting language. So that's what strikes you. Jokes apart, in my previous job, I was making device management software. So to give you an example, I would make changes on a Linux box. I would do some C change. I would have to build it, compile it, and then I have to upload it on a device where I have to, on a VxWorks. After the uploading is finished, based on the type of change, I'll have to decide whether I have to do a warm reboot or a cold reboot. If it's a cold reboot, it takes a long time. And then, finally the rendering, etc. will be done, and I would be able to see how the device management software looks like. So all these adds up, and it causes a lot of distraction. When you want to find out, when you're debugging or when you're writing something, you want to see if it works. If you have to go through these 3-4 steps, it causes a lot of distraction, which in Python is easy. You just change it and run it, and you see if it works or not. Very good for debugging, faster change verifications, etc. So that's one other thing I liked about Python. Since we don't have compilers, we don't have to do static typing. So earlier, whenever I declare a variable, I had to put in some kind of thought, what type is it? Sometimes I would have to worry about platforms, like even if it is int, okay, how much can it hold? And that will depend from platform to platform. In Python, it was very interesting that I could assign x is equal to 6, and then I could do x is equal to high. It took me some time to understand how that works, but then I realized, or I read up actually, that everything in Python is an object. So data knows its own data type, and variable is actually just a name tag. So that was something cool. I never thought that that problem could be solved that way also, but it was interesting. And there are links that, like pythontutor.com, visualize, etc. There are places where you can see how data changes it visually if you assign data and change it like this. So that is a cool learning tool I can recommend. The other nice thing I noticed about Python is the built-in data structures. I have always known, and I have actually used hash maps and linked lists and etc. But in Python, I realized that it was so easy to use because they are built in, they are baked into the Python. So, it's so easy to traverse a list. It's so easy to use a hash map just using the dictionary. I think it speeds up your curve to learn programming. If you're a new programmer, if you start with C, C++, you can use standard template libraries in C++, but still, it is not that easy to integrate, as easy as it is baked into Python, like these data structures. So apart from the standard int, string, etc., I love these collection data types. So another good thing I liked, actually I do miss pointers a little bit, but I haven't run into an application where I needed to use pointers. So I'm happy that I don't have to worry about pointers. So I don't need to worry about pointers in Python. And that means it saves a lot of headache. I don't have to worry about allocating memory. I don't have to worry about when to free it. The garbage collector takes care of it. And I don't have to worry about dangling pointers, which could be like, if you don't know, dangling pointer is like you have allocated memory and you have a dangling pointer to it, but you have already freed the space and you're still using this pointer, which is the most dangerous pointer, I think, because now this can overwrite anywhere in the memory, and you will have no idea. I have run into some very nasty bugs because of that. Those kind of bugs are such that they're even difficult to characterize rather than solve. It takes probably more time characterizing them than solving them, because to give you an example, there was this bug in which if you reboot the box like the 17th time, then you will start noticing some files vanishing because that dangling pointer was wiping them out. So these kind of bugs, I think, can take a lot of weekends, which are not good. I have heard that you can use pointers in Python, but if you need to, but if you don't need to, you can get away with it, not worrying about them. That's cool. The other thing about Python is I met somebody who said I got into Python because of the community rather than the language. So Python is a very big Python community who's very engaged, and very helpful. There's a lot of stuff online in open source. So chances are that if you run into a problem, it will not be posted, and the last answer will not be posted in 2003. More likely, there will be some more recent answer. More likely, there will be some more useful pointers to solve your problem. There are, and people contribute a lot. Like pip, which is the Python package index, has almost like 5,000 packages. Which is awesome. Chances are that if you are solving a problem, half of the job, or probably 70% of the job is already done. You just need to look at PyPy and find the right package. And it's so easy to just use it. You can just install it, pip install, import it, and then start using it. Which can make tasks very simple, and which is where the crowdsourcing helps, which is where the open source spirit of Python helps, the contributions help. So if you have to import a soul, import a good soul. The other thing, I guess the other presentations also highlighted that it is very easy to automate in Python. Like I was making this project, and after some things were running, I decided to, I wanted to test it. Now testing took so less time because there are so many tools available for testing, depending on from small projects to complex projects. They're like unit test and nose, and I don't know. I saw the list of testing tools, and it was more than like 60 or 50 on Python wiki. So there are so many tools to help you easily automate testing, and not only testing, even documentation. Automating documentation is easy because of docstrings, pinks. Logging is very easy because you can just import logging. I decided to introduce logging in my project after it was finished, and it took very less time. I just needed to import logging, and that's it. It was more like using printer. It was as easy as using logging statements. This is just to show an example how easy it is to make a test. You just import it, and then you can run it, and when you run the test, you'll see the coverage. You can see more data, metadata about your test, what failed, what did not fail, how much was the coverage. All in all, Python makes it easy. I guess the keynote speaker sort of emphasized on the same thing, that you feel empowered because it's so easy to use at times until you get into the details, and then that will be different. But it's very easy to get onto and start with a new application in Python. As a beginner, I think it's very empowering. So the other thing which I felt was Python is very diverse. The interpreter is extensible. You can do a lot of things. You can in my project I was able to do so many things, like create a dashboard using Flask. I was able to create a database using SQLite. I was using Supervisor to manage different processes in my project. I was using RabbitMQ for input-output handling. And all these things can be done so easily in Python. That was interesting because previously, okay, we'll do most of the data structures and algorithms in C. But when it comes to web interface, I'll have to start looking into JavaScript and something that can communicate to JavaScript. Somehow I can get my data structures to the web template or the command line interface or something. In Python, these gluing to each other, gluing from one place to another becomes very easy. It's a small core language with a very large standard library and with a very extensible interpreter, which makes it very diverse, I think. This is sort of the concluding slide, like how you can feel empowered by learning a Python in a day or two, and import anti-gravity. And learn about dynamic typing, whitespace, etc. I could relate to it when I saw it. I don't know if we have more time, but I have more resources at the end of the slide, which I guess in my previous, the presentation before me already talked about the importance of virtual environment. If you are going to start looking into starting your first Python project, you will need virtual environment to manage dependencies so that they are not system-wide dependencies, but project-based dependencies. You can contain them. This is sort of like a template directory structure, which is good to start with. When I started, I was looking for it. Thankfully, there were Python projects on our local wiki, so I followed this template. I know we should not use templated setup py, but if you want to use, here is the template. I was using Vagrant. If you don't want people to get into the details of how to run the project, how to install, how to do that, you can just use Vagrant, and Vagrant will spin up a virtual machine, run your processes, and people who are using it don't need to worry about it. And if you're running different processes, you can use Supervisor to manage different processes. And I have given like these simple command lines, which are like the basics of it, which you might use. You can definitely go on detail. And there's a lot of stuff on Python online. And the purpose was that it can get overwhelming. The purpose was to consolidate it in this place, and then you can go and look into the details. That's pretty much it. If you have any questions, let me know. And find me on GitHub or something. Thank you. Any questions?